In this video, we're going to continue our discussion of limits at infinity. So this is part 2 of this series of videos. And so we had left off, we did part A and part B in the part 1 video. So determine the end behavior for the following rational functions. So the end behavior, that means essentially asking you, does it have horizontal asymptotes or does the graph go to positive infinity or negative infinity? So what is it doing as x goes to the infinities? So that's what we want to do. As x goes to infinity, what are the y values doing? So let's look at this. Now notice that this one, x, is x to the first, and then we have 4x squared on the bottom. So in this case, we couldn't even be able to do the long way of doing long division because we can't do long division when the power in the numerator is smaller than the power in the denominator. So this is a good example of when we need the other method. So first identify the highest power of x that appears in the denominator. So that would be x squared. And then we divide everything by x squared. So divide every term by x squared. And so what that's going to look like is I'm going to take the limit as x goes to infinity of x over x squared plus 1 over x squared over 4x squared over x squared plus 8x over x squared. If you don't want to do this particular step, at least tell me that you're doing this, that you divided every term by whatever you're dividing by. So have your limit notation. So x over x squared, that's just 1 over x. There's nothing to simplify on the second term. 4x squared over x squared, the x squares cancel, I'm left with 4 plus 8 over x minus 1 over x squared. And as x goes to infinity, what happens? Everything that has an x on the bottom is going to do what? Right? As x goes to infinity, that means x is getting arbitrarily large. Think 100, 1,000, 1 million. So 1 over 1 million goes to 0. 1 over 1 million squared is going to get really, really small. Right? It's when I say goes to 0, it doesn't equal 0. It just gets really, really, really close to 0. So we're going to be left with something really close to 0 in the numerator and 4 in the denominator. 0 over 4 is 0. So as x goes to positive infinity, the y values are getting close to 0. So, and the same thing can be said as x goes to negative infinity. The limit is as x goes to negative infinity of our function is also going to go to 0 because we can do the same work. So in this case, whenever I'm dividing by the x squared, I can think about doing it plus or minus infinity. So it still goes to 0. So that means that our function has an horizontal asymptote at y equals 0. So what is the end behavior of the graph of that function? It has a horizontal asymptote at y equals 0. Now what about for this one? So notice that they are pretty much, they're just reciprocals of one another. I have x plus 1 in the numerator here, 4x squared plus 8x minus 1 in the denominator. Here is flipped, so this is the reciprocal, so does it change how we do it? Yes. So the process is still the same. We identify the highest power that appears where? The denominator. So even though that one is higher, it doesn't matter. We're looking at the highest power that appears in the denominator. And so when I take my limit as x goes to infinity, we're going to divide everything by x now. So I'm going to have 4x squared plus 8x minus 1. I guess I didn't color code my first example. So now I'm dividing by x. So I'm dividing every term by x. And we do the same thing on the bottom. So x plus 1, but divide every term by x. And so as x goes to infinity, I'm going to have 4x squared divided by x is 4x plus 8. Here the x's reduce, minus 1 over x, all over 1 plus 1 over x. So now what's happening? So anything that has an x in the denominator, so this guy and this guy are going to be going to 0, right? X getting arbitrarily large means, again, think 100, 1,000, 1 million. 1 over 1 million is going to get really, really close to 0. So those are going to 0, but these are not, or these are staying, right? So it looks like I'm left with the limit as x goes to infinity of 4x plus 8 over 1, so I don't need to write that. But as x goes to infinity, what is 4 times infinity doing? This is going to infinity. So do we have a horizontal asymptote? No. Right? Does that change as x goes to negative infinity? Yes. So our process up there is going to be the same. If I do the same dividing by x, I'm going to have the same term here. But as x goes to negative infinity, so let me highlight that. As x goes towards negative infinity, what does 4x plus 8 do? So this means x is getting arbitrarily large towards the negative side, so think negative 1,000, negative 10,000, negative 10 million. So what's 4 times negative 10 million? So that's going to be negative infinity. Okay, so limit as x goes to positive infinity goes to positive infinity. Limit as x goes to negative infinity goes towards negative infinity. So this function has no horizontal asymptotes. To have a horizontal asymptote, that means that the limit towards either of the infinities has to be a number. So no horizontal asymptotes exist for this one. So notice the big difference between these two, right? This one had a horizontal asymptote at 0. This one does not. And so we kind of start coming up with shortcuts and rules that were like, oh, when we have, what was the other one from the prior video? Notice that when the powers are the same, right here we had x over x plus 1, same power, we did have a number as the limit, 1. For this one, x to the 4th, x to the 4th, the powers are the same in the numerator and the denominator. We got a number for the limit. And what do you notice about that number? Right, is the coefficients. So it's the quotient of the coefficients of that. I have 15x to the 4th and 5x to the 4th. The limit was 3. So when the powers are the same, is the ratio of the coefficients. When the power on the bottom is larger, the limit is 0. When the power on the top in the numerator is larger, then the limit is, there's no horizontal asymptote. The limit is either infinity or negative infinity. So with that said, let me add one that is not in the uploaded notes. What if I say find the limit as x goes to infinity of 2x to the 5th minus 2x plus 1 over 8x minus 2x cubed plus 10. Actually, sorry, let me make it 8. 8x to the 5th. So based on what I just said, what do we think this limit will be without doing too much work? So we're going to notice the powers, right? So the power, what's the highest power in the denominator? I have my 8x to the 5th. What's the highest power in the numerator? 2x to the 5th. So since the powers are the same, this limit is going to be, and we're going to positive infinity, I guess I don't need my notation here, is going to equal just the ratio of the coefficients. So 2 over 8, so 1/4. That's kind of like to check your work. I still want to see you do some algebra, right? I still want to see this method done, but it's a quick way to get the limit. Like, oh, I am going to have a horizontal asymptote. It should be, the powers are the same, so it's going to be the ratio of the coefficients. So 2 over 8, so 2/8, which reduces to 1/4. So that's kind of like a quick way to see the end behavior of a function. So let's try the other examples. All right, let's look at this example. This is a much more complicated limit example, and we're looking at the limit as x goes to infinity and the limit as x goes to minus infinity here. So the reason that this is more complicated is because we have that square root in here mixed in with everything else. So no, we're not going to multiply by the conjugate. We're not going to do that because we're doing limits at infinity. So here we're still going to identify our highest power that appears in the denominator. So at first glance, you might think like, oh, it's x to the 6, but that x to the 6 is inside the radical, right? So then what is it really? So if you have the square root of x to the 6, what is that? The square root, right? That is then x to the 6 to the 1/2, so power to a power you multiply. So we are going to get an x cubed, but I am taking the square root, right? So this is really plus or minus x cubed, or a better way to say plus or minus is the absolute value of x cubed. So we'll keep that in mind. That's going to come in handy, right? Because we're going to positive infinity, we're going to negative infinity. What do we know about absolute value when we're approaching a negative? Or when it's negative, right? Remember the absolute value of x is defined to be x when x is greater than or equal to 0, or negative x if x is less than 0. So when we're going to negative infinity, we're taking negative values here. So we're going to use the negative x cubed essentially. So we'll come back to that. Okay, so identifying the highest power in the denominator, it is going to be x cubed. And even here, right, the square root of x to the 6 is x cubed, so it's the same. So we're going to divide top and bottom, divide every term by x cubed. And so the way we're going to do that then, I'm going to have the limit as x goes to positive infinity first of 2x cubed over x cubed divided by the big fraction, and then 4x cubed over x cubed. And what happens here? I can't just divide by x cubed, right? We have, this is the 9x to the 6 is inside a radical and x cubed is not. So I can't just say bring in an x cubed and divide there. So I'm going to use this fact that x cubed is equal to the square root of x to the 6. So when I bring it in, it's going to be dividing by x to the 6 on the inside. So dividing by x cubed on the outside is the same thing as dividing by x to the 6 inside the radical. So what that's going to look like is the square root of 9x to the 6th plus 5x to the 4th over x to the 6th, x to the 6th. So let's pause that for a second. I just want to go over that again, right? I can't divide by x cubed inside the radical because they're not like terms. So in order for me to divide by the x cubed, I need to put it inside a radical. So x cubed is the same thing as the square root of x to the 6th. Now I can bring it in. And so let's see. So the limit as x goes to infinity is 2 in the numerator, right? Those cancel. 4 in the denominator plus the square root of 9 here plus 5 over x squared. So as x goes to infinity, this is going towards 0. And so what am I left with? So 2 over 4 plus the square root of 9. The square root of 9 is 3, so 2 over 7. So that's my limit as x goes to infinity. So y equals 2/7 is a horizontal asymptote as x goes towards positive infinity. Now what happens as x goes to negative infinity? So as x goes to negative infinity of the same function, my 2x cubed over 4x cubed plus the square root of 9x to the 6th plus 5x to the 4th, we're going to do the same thing, right? But now, because x is going towards negative infinity, we're going to use this definition of the square root of x to the 6. The square root of x to the 6 is the absolute value of x cubed. So as x goes towards negative infinity, right, that means that x is less than 0. So the absolute value of x cubed is negative x cubed. So I'm going to be dividing by my x cubed, but then this one is going to be a negative x cubed. And with the negatives, a better way perhaps to think about it will be to think about factoring out that cubic term, right? So if I say I want to factor out the x to the 6, so I'm going to take out the x to the 6 and I'm be left with the 9 plus 5x to the 4th over x to the 6 because I'm taking out the x to the 6, right? So the idea with factoring is that when you plug it back in, but not when you plug it back in, when you multiply it back in, you get what you started with. So x to the 6 times 9, 9x to the 6. X to the 6 times 5x to the 4th over x to the 6. The x to the 6 will cancel, leaving me with just 5x to the 4th. And the reason that this might be more clear is, hopefully, is that now I can see that, oh, I have that square root of x to the 6 here. So I can say this will be the limit as x goes to negative infinity of 2x cubed over 4x cubed plus now the square root of x to the 6 is the absolute value of x cubed times the square root of whatever's left inside the radical. And that will be it. And so now as I go to negative infinity, now that's where that x to the cube absolute value comes in handy, right? This is going to be x to the cube, x cubed when x is greater than or equal to 0, or negative x cubed when x is less than 0. Since we're going to negative infinity, it's going to be the negative x cubed. So as I start dividing by the highest power, right, this is multiplication, so I have to divide the whole term. I don't do that and that. This is multiplication. So as long as I divide the whole thing, so this will cancel, not really though, by giving me a negative 1. So because I'm substituting the absolute value of x cubed is equal to negative x cubed based on that definition. So this is going to be the limit as x goes towards negative infinity of 2 over 4 minus, right, because negative x cubed divided by x cubed will be minus 1 square root of 9 plus 5x squared. And as x goes to minus infinity, this guy goes to 0, and I'm left with, what are we left with? 2 over 4 minus the square root of 9, which is 3. So 2 over 4 minus 3, so just 2 over 1. So 2. So that means that the graph of this function, we have horizontal asymptotes. We have 2. We have y equals 2 as x goes towards negative infinity, and y equals 1/8 as x goes towards positive infinity, based on our work from above. And so this is why I know that in prior videos I've been really emphasizing the definition of the absolute value, and it's because it does show up a lot in this class. And so this is one of the places where it shows up. The square root of something squared, right, is the absolute value. And so then we have to look at, especially with limits going towards a negative number like negative infinity, we have to look at the definition of the absolute value. And it only applies to where the square root is. So I'm not dividing everything by a negative x cubed, just that one. Right, so those are our horizontal asymptotes for this particular problem. So let me give you one to try on your own. So let's find the limit as x goes to plus or minus infinity of, let's say, the square root of x squared plus x minus 1 over 8 minus x. So try that on your own as x goes to positive infinity and as x goes to negative infinity, and see what kind of asymptotes you get, if any.